whole thing is a black hole.
They're way too massive.
Yeah.
Okay.
It doesn't make any sense.
It does. Okay.
Okay. Back in July 2022, JWST came online. I was traveling in Europe and it was a whole frenzy. And within 2 weeks of when the data was released, we had headlines like this from the Scientific American that said the first glimpses of early galaxies could break cosmology. You know, JWST was seeing universe breakers. And what it was all about was there were these spots of red light everywhere at really high red shifts. And if they're really far away, that also means that they're very young for the universe, right? Because the universe was less than 1 billion years old and we were seeing galaxies. And in order to make galaxies, you need a lot of time.
Right.
Because it takes time to form stars and then from those stars to amass and become a clustered, gravitationally attracted object like a galaxy.
And this idea is based off of our current like cosmological models of the mechanics and the dynamics of the early universe.
Yes, yes. Based on how much we know dark matter is there, how much we know dark energy is there. Those models of our universe tend to not have galaxies so young.
Right.
Okay. So these became these universe breakers. And then the debate was, okay, maybe they're not star-filled galaxies, but maybe they're just weird massive black holes.
Okay.
And the other thing about them is they're really small. Okay. They're really, really small. If you look on the right-hand side, on the left-hand side, we've got one of the JWST deep fields. And on the right-hand side, we have a close-up of one of these red dots. And they'd be about 150 to 500 light years across. The Milky Way is on the order of 100,000 light years.
Oh, okay.
Okay. The Milky Way is much bigger than these things by a factor of 100 to 1,000.
Okay.
So perhaps they are just like black holes. This is the first clue. They have a lot of activity and a lot of mass. So yeah, seems like a black hole.
It tracks.
Okay. So if it's a black hole, we'd like to calculate its size.
Right.
Okay. You get something like a number that is 1 billion to 100 million, tens of million times the mass of the sun. So you would think that, okay, we're good, right? Like they're not galaxies. They're just black holes. Not so fast. These black holes are way too big for whatever galaxy this little red dot is. If this little red dot is a galaxy and at the center is this active galactic nuclei that's, you know, churning up a bunch of mass and then spewing it out as radiation, then those black holes are about 10 to 100% the host stellar mass. Okay? In contrast, for our Milky Way, the center of the galaxy where the black hole is, that black hole is only 0.1% of the entire mass of the Milky Way.
So this is, the math is not mathing.
The math is not mathing. Okay, so here I'm getting 10% to 100% the total mass.